All right, here we're going to be learning about the perimeter of composite figures. So a composite figure is just more than one simple figure squeezed together. It's multiple simple shapes. It's the combination of multiple simple shapes. So like a triangle and a circle or half a circle pushed together is a composite figure. It's just more than one simple shape. All the simple shapes I'm talking about, like a triangle, a circle, rectangle, even a trapezoid, are all on your formula sheet, so that's going to be really handy for this unit. Before we get into actually using the formulas, let's just talk about what perimeter really means, or some keywords to look out for. We could say the outside of a shape is the perimeter. We could call it the border, or we could say the distance around a shape. It's definitely not a comprehensive list. There could be other words that you see, but those are three words that you might see or phrases that you might see to represent perimeter. So our steps for finding perimeter for composite figures, essentially we just want to add up all of the sides. That's going to tell us the entire distance around a shape. But there's going to be some missing sides that we need to find first. So we're going to highlight the entire shape before we do anything. Highlight the outside of the figure, just to make it clear what we're going to be adding up and what sides are missing. And then we're going to find those missing sides, and then we will add them up. You add up all the outside lines together to find the perimeter. All right, so to find the perimeter of a composite figure, we're going to highlight the shape. Everybody should be doing this. You're highlighting the shape, and then thinking about what sides we're missing so that we can find all the sides. We don't have this side yet, and we don't have that side yet. Everything else we have. We have that one, that one, that one, and that one. We're just missing these two at the bottom. Okay, so for a shape like this where it's just rectangles that are pushed together, you always want to look across from the side that you're missing. We're missing this side right now. Across from that's going to help us. So this red line goes from the bottom of that shape to here. So it's part of this 10. The rest of that 10 is coming from this side here. If from there to there is 6, that's also true on the other side. From there to there, that's got to be 6. So we can do 10 minus 6 to find out that this part is 4. 6 plus 4 is that whole length of 10. Well, if this is 4, so is that. So we just found that one missing side. That's got to be 4. I'm going to do the exact same thing for this one at the bottom. So I see this part's 3. This part is 6. This lines up directly with this part, so that part's also 3. This part lines up directly with this part. That part's also 6. So altogether, that side has to be 9. Because 3 plus 6 equals 9. So if you're missing a side in a rectangular shape like this, really you just always look across, and that's going to help you find this missing part. Now we have all the missing sides. We can just add them up. We're going to do 10 plus 3 plus 6 plus 6 plus 4 plus 9. Adding all those together, we should get 38 meters. We have a similar kind of shape on example 2. It's a little bit more complicated, but it's kind of the same thing. First off, let's highlight the shape. And think about which ones are missing. I'm missing this one, I'm missing that one, and I'm missing that one. Alright, so 2 of these are pretty easy. I don't really even have to do math. I just kind of have to observe what the shape looks like. I'm thinking about this one first. Well, if this is 4, that's also going to be 4. Next, I'm going to think about this one. Well, the opposite side there is 8, so that's also going to be 8. And then for the bottom side, this whole bottom side is made from this, and this put together. 4, 4, and 4 put together. So that bottom side has to be 12. 4, for this part, 4 for that part, and another 4 for that part, adds up to 12. Now we're going to add up all the way around. We add 12 plus 8 plus 4, 4, 4, 4, and 4, and then another 8 on the other side, and that gives us a total of 48 centimeters. A little bit of this is just being careful. If you happen to miss one of those 4s, you're going to get the wrong answer, so just really be careful. Go around the whole shape, make sure you get all the missing sides. All right, example 3 and actually 4, we see kind of the same thing here. So I'm going to highlight the shape first just to figure out what my perimeter really is. So I'm missing this part, and I'm missing that part. So, anytime you see a slanty side like this, that's a part of a triangle. You can see we have a triangle here. That's telling you use Pythagorean theorem. This is one of the equations that's going to be really helpful in this unit. When we're missing the side of a right triangle, you can use Pythagorean theorem, or a squared plus b squared equals c squared, to find that missing side. So I'm looking at this red triangle here. I'm missing that side, which is across from the right angle, so I don't know the c in that triangle. And it kind of looks like I don't know this side either, the side at the bottom. I'm going to redraw that triangle. I have the height, that's 3. I don't know this yet. I know that's going to be c because it's across from the right angle. I actually could figure out this bottom side. Looking at this and this together, 4 lines up with that part. That part has to be 4 also. These are the same. And then I know that the whole thing is 12. So if I do 12 minus 4, that tells me that this part has to be 8, which is the exact same thing as that part. So that part at the bottom of that triangle has to be 8. Now I can use Pythagorean theorem. I have two missing sides. I have two sides of the triangle. I have the a and the b, and I have that one missing side, c, that I want to find. So I'm going to do 3 squared plus 8 squared. That equals c squared. So that's 9 plus 64 equals c squared. So that's 73, which equals c squared. And then we do the square root of 73 to find out that that slanted side is 8.54. So that is this missing side at the top. I don't really need that 8 anymore. I need the 8.54. The 8 was this dashed line that's in the middle. That's not really a part of the perimeter. Right, the only other part that I really need is this other question mark on the left side, this purple question mark that I wrote before. So I'm thinking this side lines up directly with part of this 8, and the 5 on the other side also lines up with part of the 8. So 5 takes us from there to there, and I know that the entire thing is 8. So if this part of it's 5, that part has to be 3 to get us up to a total of 8, which means this side is also 3. Now I have all my missing sides. I'm going to add them up. I'm going to say 8.54 plus 8 plus 12 plus 5 plus 4 plus 3 plus another 3. I'm going to add all those up. Some people question whether 4 is a part of the perimeter. It is on the outside. Even though the 4, the number itself, is written on the inside, it's labeling the outside. That's really all I care about. It's labeling a part of the outside, that 4. So we're going to add all those up and get 43.54 centimeters. I see the same kind of thing happening here. I'm missing some slanted sides there. So I have to find that side, I got to find that side, and I got to find this side. Those are my missing sides. I'm going to deal with this one first. So I have that triangle. We have 2 labeled there for the dashed line, 2 labeled there. And I have a right angle here. That's telling me I can use Pythagorean theorem to find that missing side. The 2, both 2's are my A and my B. I'm looking for C, it's across from the right angle. So we're going to do 2 squared, get 4. 2 squared again, 4. 4 plus 4 is 8. And then we do the square root of 8 to find out that that side is 2.83. So this blue side that I drew down here is 2.83. I'm going to do the same thing for this triangle. I see that's labeled as 3. The bottom side is labeled as 4, and there's my right angle. So again, I'm looking for C here. So I'm going to do a squared plus b squared. That equals c squared. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25, and then the square root of 25 is 5. So C for that triangle is 5. Alright, then I got one more side to find. I'm looking at, let's change to purple. This side that I have to find. That side's coming from the sides that are across from it. This part, from there to there, so from there to there, that part's 8. The last little bit there is 2. So altogether, that side is 10. I'm going to clean this up just so I make sure I don't count something that's not really a part of the perimeter. And I'm just going to go around the shape and add everything up. 4 plus 8 plus 2.83 plus 2 plus 3 plus 10 plus 5. Altogether, that gives me 34.83 feet. Whoops, that's not supposed to be there yet. All right, the second equation, or really the second and third equations that we might be using for perimeter are the equations for circumference. So circumference is just another word for perimeter of the circle. It's the distance that goes around a circle. So this is only half of a circle, but we're going to need to pretend that it's a full circle first. Think about finding the full circumference of the circle, and then we cut that in half. Same kind of things happening here. We have half of a circle there. We're going to pretend it's a full circle. Find the circumference of that circle, and then divide that by 2. There's 2 different ways we can find circumference. You'll see this on your formula sheet. We have 2 pi r. So that means 2 times pi times the radius. Or you'll also see pi times diameter. Either one of those works to find circumference. The radius is halfway across the circle. So let's look at example 6. That is the radius. 3 is the radius of that circle. That's going halfway across. The entire distance across is called the diameter, so 6 would be the diameter of that circle. On example 3, the diameter of the circle is 4. So again, you could use either of these 2 equations. They both find circumference. It kind of just depends on what you're given. If you're given the radius, use the one that uses radius. If you're given the diameter, use the one that uses diameter. Alright, so let's highlight the shape to make sure we find all of our missing sides. So we're missing this part of that circle, we're missing this bottom side, and that's it for this one. So I'm going to find the distance going around the circle. Again, I'm pretending it's a full circle, but then I'm going to cut that in half because I really only have the left side of that circle. So circumference equals pi times diameter. I'm just choosing to use that one because that's the information I'm given. I'm given the diameter there. So I do 4 times pi, which tells me that if I had the full circle, it would have a circumference of 12.56. I don't have the full circle. I only have half of that circle, so I divide that by 2. And that tells me that that half circle is a distance of 6.28. The other one should be pretty easy to find. Those are the same length, so that's 6. And now we're going to add all those together. 6.28 plus 6 plus 3 plus 5 plus 6 is 26.28. Last one, same kind of thing. I need to find the top half of that circle. I'm also going to need to find this slanted side. I'm going to need to find part of the bottom. And that side I actually already have. So I'm missing this, this, and this. So again, I'm going to pretend this is a full circle. I'm going to find the circumference. This time I'm going to use 2 pi r because that 3, that's only going halfway across the circle. That's the radius, like I'm saying there. So 2 times pi times the radius. So 2 times pi times 3 is 18.84. Don't know why that's going out so slanty. That's if I had a full circle. I'm going to divide that by 2 to find out that that top part is 9.42. This part lines up directly with this part. 3 is going halfway across the circle. This is another 3, so altogether that has to be 6. And then the last side, it's part of this triangle. So I'm going to redraw that triangle. That has to be the height of the triangle. That's got to be 4. The base of the triangle is also 4. So I'm going to do 4 squared plus 4 squared. 4 squared plus 4 squared equals c squared. I'm looking for the longest side in that right triangle. So I'm going to do a squared plus b squared, get 16 plus 16, which equals 32. And then we take the square root of 32 and find out that that missing side is 5.66. And those are all of my missing sides. I'm not going to include anything on the inside. So this 3, the other 3 that I'm given there, those are not a part of the inside. You just go around the outside of the shape. 5.66 plus 4 plus 6 plus 4 plus 9.42 adds up to 29.08 meters. All right, I hope this helps. Practice with those 4 at the bottom.